Today I want to just show you an application of some of the tools that we've been working with here. Let me start sharing screen and clean this up. I've got a little game that's a game of tag, and this game of tag builds on the idle run jump that we made for our character. That's what we're going to use for the character who's it in the game of tag, and follow, flee, and the chasing AI scripts that we used with the dude for the ones who are being pursued, the autonomous agents. And what makes this game a little more interesting and of course more complex is that when one tags another one, that other one becomes it, and the game continues with the player now in control of a different character. And so this is going to look something like this. I've got all my characters, but I got the gladiator, who's the slowest character. But when I tag another player, it exchanges, and I'm in control then of a different character. So this is all going to be coordinated with 3 communicating scripts. There's the who is it script, which is kind of a central manager. It's on a game object in the world, and it's keeping track of all the different characters, and it's mediating this exchange. There's the tag AI, which is on each character, and this is the motor that controls each character. When they're it's going to handle player input, and when they're being chased, it's going to handle the AI thinking. And then there's TagCollision, again, a script that's on each character. And this one is going to handle the interaction between any 2 players whose roles must exchange. So the tag AI script, the motor that's on our different characters, in its update function does 2 simple things. One, it sets a global distance, which is how far it is from its target. And then it decides, based on whether it is it or not, I am it, a Boolean that we'll see is set elsewhere, whether it's going to do the idle run jump and be player controlled, or whether it's going to do the be chased and it's going to run away from the person who's it. So idle run jump is exactly the same function that we used with our character back when we were doing mechanism animation. I've added a little state to the function, and this actually doesn't participate in any of the logic. It's just kind of there for debugging purposes. It's an exposed variable, so I can see it in the inspector, so that I can see what state the character is in. But otherwise, it just does all the usual stuff, horizontal and vertical axes, setting animators' speed and direction, and this controls our little running character. Be chased is a very slightly modified version of the chasing AI script that we used with the dude. It takes advantage of that global distance that we set. I don't think cur dist is used, but it's there for to be exposed so that we can see it in the inspector. And it does its logic. If it's too close, it flees. If it can see and it can jump, it jumps. Otherwise it chases. And if none of these are true, then it does the idle, which is where it turns and scans the environment for the player. I've also added a little sound script here, if it has an audio clip, it either plays or stops that audio clip. So this is just a little addition. The usual helper functions that we've got to keep the code clean. We've got too close, which checks the line of sight and uses that global distance. We've got too far that just tests the global distance. We've got line of sight. If I take this return true line and turn it on, then that lets it see through anything. But otherwise, we're doing a raycast out some distance. I have the source position of that raycast set to be a little bit up from the transformed position. The position of these characters is at their feet, so we want that line of sight to come out of their head. And this just uses this raycast. If it hits something, it tests to see if it's the target, in which case it returns true, otherwise it returns false. And if it doesn't hit anything, it returns a false. Can see, again, the global distance. And this is that angle that we can see. And of course, can jump is if we're at the right distance to jump. So the idle, chase, flee, and jump are all similar to what we did in chasing AI, except I've added this little state that, again, is just for diagnostic purposes. So the idle just sets speed and direction to 0. Chase figures out the wanted direction that it wants to go, and it does this little trigonometry with the dot product and the cross product to figure out how it turns, and it sets the animator's speed and direction. Flee, of course, is just the opposite of chase. We've got this extra minus sign in here, so it runs away from our player instead of toward our player. And jump, of course, just keeps the AI turned towards its target by doing this rotation thing with a quaternion slurp. So this just keeps our AI pointed at its target. So the exposed and private variables of this tag AI script, here's the state that is just for us to see. There's the I am it, which we're going to set from various other scripts. And then the rest of this is, and the audio clip that we want it to play when it's jumping, and various privates for these different states that we use in our tests. Now, the TagCollision script, and each player has one of these. Only one of them is active. You'll see that I'm going to turn off all of the TagCollision scripts except the one that's on the one who is it. And so the TagCollision here in start finds the who is it controller. This is the game object that has the who is it script on it. This one has only an on trigger exit that of course, an is trigger collider that is going to trigger the exchange of who is it. And it's doing this by setting the new it on the who is it script and the change variable to true on the who is it script, that central manager that is handling the actual exchange. So this TagCollision, only one of which is active, is going to handle this, is going to trigger the exchange by setting these things on the who is it script. So the who is it script, this is on some empty game object in the world, the who is it controller, and the who is it script has the runtime animator controllers that I'm going to use and switch between. One of the controllers is the idle run jump that we used with the player control character, and the other is the seek animator controller that we use with our chasing AI. Here are those public variables that were set here in the TagCollision, the new it and the change. New it is now this other game object that has collided with the trigger, and the true means that it triggers some action in the who is it script. The rest of this stuff is just internal bookkeeping, things like arrays of the players and other stuff. So in who is it, I'm going to use the awake to set things up. And I do this because I want it to happen before the starts. Awake and start are very similar. Awake happens before starts. Remember that A comes before S, and so awake comes before starts. This is one of the things we do to enforce the order of things, because we don't know the order in which all of the start scripts get run. We might find that some things had not been enabled or had come into existence or done whatever they had to do before another start script tried to access them. So in this case, I'm going to use the awake, and in the awake, I'm going to find all the players. They're all tagged TAG, and so I'm going to find all of them, and I'm going to also find the main camera, and I'm going to find the overhead camera. Now, still in awake, and this is before any of the other scripts have done their starts, I'm going to, first of all, pick a random character to be it. So that's out of this random range between 0 and number. Number is the number of players, the player's length, and I'm just picking a random number in that range, 0 to number -1. And that's who is it, the player it. Each of these players have an object on them that's named _target. And so I'm going to find that target and put it in tag target. This is only on the who is it object. I'm going to find its target and assign it to tag target. And then I'm going to go through all the players. And I'm going to access their TagCollision scripts, and I'm going to turn it off. And I'm going to access their Tag AI script, and I'm going to set them to be not it. And some other stuff, I'm assigning its target, that's this tag target. And then I'm setting the size of the far distance, the jump distance, and the close distance, so that everyone's using a consistent set of distances. And then I'm going to access its animator and set the controller to be seek. So all of them now have their TagCollision turned off, their Tag AI set to be false, and their animator controller set to be seek. And then I'm just going to go ahead with the one that's it, accessing its TagCollision, turning it on, so only the one who's it has an active TagCollision script, and I'm setting its I am it to be true. And you remember the I am it in the Tag AI decides whether we're idle run jumping or chasing. And of course, since I am it is run by a player, I'm setting its animator controller to be idle run jump. So everyone it has their tag collision off, knows that it's not it, is using the seek controller, except the one who's it, whose tag collision is on and who knows it is it and is using idle run jump. So we're actually switching controllers here as things go on here. Oh, and I have to, of course, update the targets of the two cameras. So the camera that's watching our player gets the target as who is it, and the overhead camera also gets its target as the who is it. So the cameras are going to watch the one who's doing the chasing. Now, in the who is it controller, the update function does nothing except watch the change variable. And if the change variable is ever true, it's going to call the exchange function. Now, you remember back in the TagCollision script, when it collides with something, when the one active tag collision on the character who is it collides with something, it's going to set the new it on the whole who is it the who is it script, and it's going to set the change to be true. So that little loop here that's just watching the change variable is only going to call exchange when change gets to be true. And as soon as it's done the exchange, it's going to set change back to false again, so that it doesn't call exchange again. So exchange is kind of similar to awake. It's doing the same kind of stuff. It has this new character who is it, the new it that was set by that tag collision. I also have a little cooldown time here, a wait time. This was to prevent more or less instantaneous tag backs. I found that when my players collided with each other, if I didn't provide a cooldown time for them to disentangle their colliders, that it would just pop back and forth between the same one. So there's a little cooldown time here in the exchange that prevents that sort of instantaneous tag back. So I reset my new its transform position to be the who is its transform position, thrown forward and up a little bit. And then I go through all of the different characters and set their tag AI to target. So I've found the new target on the new one that's it, and I've assigned it to all of the different players. Here I'm going to set the old one who was it to not be it anymore by turning off its tag collision and setting its I am it to be false and setting its animator controller to be the seek. So this turns off the one who was it prior to the collision, and then it turns on the new it tag collision script gets enabled. Its tag AI I am its variable is set to be true. Its animator is set to be the idle run jump, and so the new it is now the one who's doing the chasing. And then I update the cameras to follow the new it instead of the old it, and just for fun I instantiate a little poofer here to make a particle effect when they collide. The TagCamera script that has that target is fairly simple. It points to the, uses the transform look at to point to this follow position that is some distance up and away from my character. And I've got a little bit of lerping here to keep it from following rigidly. It kind of follows with a little bit of lag. And of course, the overhead camera does essentially the same thing, except it's, of course, a little bit simpler. This overhead camera is pointed down into the world, and so in the look at, I wanted the up vector in my view to be the forward vector of my target, so that the overhead camera kind of follows the target as it runs around in the world. And so here's the behavior of this thing. Takes forever when Zoom is running. So I have a number of different worlds, the simplest one being this flat world. And I don't know if you can hear them, but the audio script is Marco Polo. So when they get close enough, they start saying Marco Polo. I'm going to mute that for the time being. So I run into these different characters, and whoever is it exchanges, and with the exception of these guys with the little short legs, none of them can catch each other just by running. So we've got that world. M goes back to the menu. So I've, of course, done this in different worlds. I've got one that's static time, where the time doesn't change. I have on here a little script that controls my sunlight, the light that's the sun. And so this is a little script that I kind of borrowed from a Sky Dome script that I found somewhere, and it kind of adjusts the time. So it's 6:20 in the evening here. The sun is approaching the horizon, and it's going to get dark at some point here. It's going to get dark at some point here. And I've got a moonlight that's illuminating things during the nighttime. Was that fast time? The time script is kind of an interesting one. The time script, the Sky Dome script, I'm sorry, that's going to open an editor. The point of the Sky Dome script is that you can set the Julian date, what day of the year it is. You can set the longitude, and you can set the latitude. So I've set it for 45 degrees, which is basically where we are here in Orono. And you can set the time and the time speed factor, and this is going to control how the sun moves in the sky. And it's going to open an editor here. This is actual orbital geometry for the Earth in orbit around the sun, with a tilt of 23.5 degrees, and the different seasons of the year. So this is a little script that you can use to control your sunlight. And just for fun here on the sunlight, I have the kind of bright daytime sun, and I have I call it the starlight, that is a purplish color for nighttime, not so intense, strong indirect multipliers. And these two point in different directions. The skylight points towards the ground when it's daytime, and the starlight points the opposite direction, so that it comes up when the sun goes down. And so I have these various worlds in which I can play. So I have fast time that is just kind of a quick demonstration of the use of this sky dome to change the lighting as time progresses. There's a slow time that's a bit more realistic. I have a couple of different weather conditions. I have fog, which uses this kind of global fog to make the world a whole lot more mysterious. But the mechanics here of chasing is essentially the same, and we can run down our characters in the world. We can't actually run them down. We have to trick them into exchanging. And I believe there's also a snowstorm that uses a particle effect to generate snow that falls on our landscape, and using the sub-emitter leaves snow that kind of sticks to the ground. And of course, this one turns out to be fairly laggy. You notice my frame rate counter is abysmal here. And of course, just for overkill, both fog and snow going on here. And so we're in full kind of stormy conditions. And of course, with all these particles, it's beginning to get pretty laggy when I'm playing with zoom on. So let me stop sharing here and entertain any questions about tag on terrain. And I'll remind you all to type your names in chat here. Any questions about tag on terrain?
You said one of the world was like static time.
Static time just meant that my sky dome had a rate at which time passes of 0. So the lights weren't turning. That sky dome script, you can just set the speed of the time to 0 and it doesn't move. You can set the time of day and the latitude and the longitude and the day of the year so that you get the sun angle that would correspond to a particular day of the year at a particular longitude on the planet, at a particular latitude, at a particular time of day. And so the sun is going to be realistically where it's supposed to be in the sky. I thought this was a very cool script. You can look at the script. It's a bunch of advanced trigonometry with, orbital mechanics and so forth in it, figuring out all of the geometry of the Earth in orbit around the sun. It's pretty cool. Any other questions? Let me look in chat and see if there's anything. Nope. Okay. So let me go back to sharing here and move on. Let me close this one up. And here's that script, which does a bunch of trigonometry here, setting the position, a lot of sines and cosines of the latitude and the longitude, calculating direction, converting spherical to Cartesian. And I didn't write this. I stole it from an asset that I found somewhere and simplified so that it's a lot easier to use. So let me get another one going here. Whoops, I did wrong button. I want this button. Teleport. So we're going to do some teleporting here. So often in these worlds, often in these worlds, we've got some big landscape that we have to slog across, and wanted to set up some devices for teleporting from one location to another quickly without any fuss. So we want to be able to walk into a portal and have our character appear instantly someplace else. And if Unity ever opens up, I'll show this. So this is going to be set up very similarly to the way we did the pickups, the damage items. We're going to have a collider that's set to be is trigger. It's going to have a rigid body that's going to be set to be is kinematic. And it's going to have a script on it that instead of damaging our player, teleports our player. So all of this is very similar to what we did with the pickup and damage items. And here's how it's going to work. I've got this red object that is my teleport device, and I have my green objects that are where I'm going to teleport to. And if Unity ever gets going, I'll walk into the purple and I come out of the green, and I can cycle back here and walk into the red, and so I can teleport around my world by walking into this teleport device. Now, you could teleport to a specific location. You could put in a vector-3 location in world coordinates, but of course, that's kind of a hard way to keep track of things. And so in a lot of ways, it's easier to just place an object where you want to teleport to, and have that location of the object be where you're going to make your character appear. And this is the method that I'm going to use. So I have a teleport from object, that's the red thing, and I'm going to have several teleport to objects, that's the little green objects. So in my simplest teleport script, teleport 0, I have a public array of transforms that are the teleport to objects, and I've got a private integer number that's the number of those things that I get from teleport to.length. So I need to load into my exposed variable all of the teleport to devices. So if we look over here in the teleport from here, I've got a teleport to with 3 things in its array, teleport to 1, 2, and 3. So this is the array of potential places I can teleport to. With an on trigger enter, I just test to see if the collider that's hit it is the player. I throw a random number between 0 and number -1, and I set my collider, the player that just went into the trigger, to set its position to be that teleport to's transform position. It's as simple as that. That's all I need to do to make this teleport happen, to make the teleport happen. So I walk in and I appear someplace else. Walking into these things doesn't do anything because they're not teleport to devices, although you could set them up to be one if you wanted to. But I teleport into these different devices, picking a random one each time. Now, that teleport is not terribly interesting. So I'm going to add some sparks and some noise. In my teleport 1 script, I've added a transform for a particle effect, the poofer, and I've added an audio clip for the sound that I want it to make when I'm doing the teleportation. Awake is the same, just catch the number of these things. And in the enter, the only thing I've added is that I'm going to play the audio clip This is actually a function that I'm going to write myself, the play audio clip. It has three arguments: the clip that it's going to play, where it's going to play the clip, and how loud it's going to be. So that's these three variables. And of course, I'm instantiating my poofer at the teleport to object's position and with an upright rotation. So what's this look like? This is test number one here now. Things look pretty similar in the world, but when I run into my teleport to object, I now have a sound playing. I've got the mute on so you can't hear the sound. There's the sound. So when I run into it, it makes the sound, it makes a little particle effect, and my player comes out of the teleport too. And I better mute that because it's making a horrible racket. And probably Zoom is blocking out everything that I said because Zoom has various sound things. So so that's pretty simple. That play audio clip that I used here to play the clip at a position with a volume has its argument, the clip that it's going to play, the position at which it's going to play it, because remember this is 3D sound, so we can hear things, and its volume. And this one creates an object on the fly. It makes a game object called one-shot audio. It puts that game object at a position at the position that I'm specifying here as an argument. It adds an audio source to the game object. It assigns to that audio source the clip and sets its volume, and it plays it. And it plays it until the clip has finished. The clip length is how long the sound plays, and it then destroys the this one-shot audio that it made here. So if we watch over here, well, I'm paused. So you can see here's the one-shot audio that it created that's playing the thruster sound with, well, it just turned it, it just destroyed it, so it's gone. So as I enter into these different, as I enter my teleport, it makes this one-shot audio that is playing the sound in the world and cleaning up when it's done by destroying it after the audio clip has finished. So I'm not really satisfied with the teleportation. It's kind of quick, so I'd actually like there to be some delay. There should be some amount of time that it takes for my character to manifest in the world. And I also don't really want my game cluttered up with a whole bunch of teleport to objects when they're not active. So I'd like these green things to not be visible when they're not being used. So to my teleport to script, we had version 0, version 1, and now version 2. I'm going to add a delay. This shadows thing is just something that I don't know if it's actually necessary. It's a little object that is not visible but casts a shadow. I'm not sure whether we use it or not, but it's there just in case we do. So the delay, I'm going to set the delay to be the clip's length, that sound that I'm playing, divided by 4. So the delay is going to be 25% of the sound clip that I'm playing here. And in the awake here, I'm going to go through and I'm going to turn off the renderer of all of the teleport to objects. So I'm going to make them not visible. And I'm going to turn off their colliders as well, because I don't want to accidentally stumble upon an invisible collider that is my teleport to device. I do the same thing with the shadows. I find the shadow as a child of the teleport to device, and I set its renderer off as well. I'm not sure I'm using the shadows, but they're there anyway. So in order to enforce this delay, I'm going to change my on trigger enter to a coroutine. I do this by just making it, instead of void, I make it an I enumerator. This means I can use the weight, yields, and so forth. And I'm going to access the player's animator and the player's rigid body. The rest of this stuff is exactly the same as what we had before. Since I now have control of the animator, I can turn it off. And this is going to make my character uncontrollable. So with the animator off, it's no longer going to respond to player input. I'm no longer going to be able to walk my character, which means it's going to be frozen inside the teleport device for some period of time. And I'm also setting its is kinematic to be true, so that it has a rigid body, it can't move either. And I'm going to turn on the mesh renderer of the teleport to device, and I'm going to turn on its collider, and I'm going to turn on the shadow if it's necessary. And I'm going to wait for that 25% of the clip's playtime delay. I'm going to wait right there for a little bit. After the wait, I'll then turn the animator back on again. I'll set is kinematic back to false. I'll turn the shadows back on. Back off. I'll turn the teleport to's renderer back off, and I'll turn its collider back off. And so now here, I believe we're in test number 2. And whoops, so now we can't see the teleport to devices. They're there, they're out in the world, but their colliders and mesh renderers are off. I accidentally walked into the trigger. So when I walk into the trigger, I teleport. I can still rotate my character. I have to fix that, but it's frozen for a little while, and the devices are not visible until I emerge from them. So this is getting a little better, and I've got the mute on so you can't hear the sound, but it is playing that thruster sound. So I'm not going to have time to finish this one, but the Unity particle pack had some really cool dissolve effects where the material gradually disappeared with sparks and smoke and other stuff. And it had a script that controlled it. But I'm going to actually save that for Friday, but I'll show you how it works here. So I have my teleport to device, and when my player walks into it, the devices appear, and this is of course very laggy because we're doing it with Zoom, but the teleport to device gradually comes into view, and then we're released. And I have I think 3 of these that I figured out how to use from that Unity particle pack. Each of them works a little differently. They're really very cool, and it shows you how you can control particle effects from scripting. So this one has a little whirligig that appears, and in this case, it's the Ethan character who gradually comes into existence and is finally able to run around. And there's one more here. There's one more here. Zoom and Unity do not play well together. I don't understand why. Zoom is not a very heavy-duty program, and these are pretty simple Unity worlds. So a lot of sparks and smoke, and the player character manifests gradually in the world. And of course, I can do this. And so that, you know, these are pretty cool. And so I'll show you how to do them next time. So I'm going to stop sharing. Remind anybody who hasn't already to drop your name in chat. I'll look at chat and see if there are any questions, and I'll entertain any questions here at this point about teleporting and how we can use this to move around our world easily through kind of portal devices that go different places. And of course, they don't have to be cylinders. They can be, you know, gem pickups or doors or holes in the wall or whatever you want to make them. Any questions? Nope. All right.
Did you say that there was a way to make a teleport to device the same as the teleport from?
Yeah. Yeah, sure. You put a teleport, you put the teleport to script on the teleport, no, the teleport from script on the other objects. Well, you'd have to be a little careful with where the character manifests, because if the teleport to device had a teleport device, when you appeared there, you would immediately pop someplace else. So you put your character in this pop around world. I'll show you examples of what you're describing, which is where the teleport to becomes a portal that you can then go back into and it takes you someplace else. I have an example of that in something we're going to do on Friday. So I'll show you that.
Awesome.
Cool.
Thank you.
I'm going to stop recording here.